So for our second example, we have that according to market research, members of the Gen Z demographic, that is, you guys, watch 68, well, most of you guys, anyway, watch 68 online videos per day with a standard deviation of 3.5 videos. Suppose I believe that information is inaccurate and ask 25 of my students at random how many videos they watch and get a mean of 66.9 videos. Assuming the distribution is approximately normal for a level of significance alpha equals 0.05, is there enough evidence to support my claim? So again, first step, just basic verification. Yes, we have approximate normality. We've got a not quite large enough sample, but for these purposes, it is enough. We also know what the mean and standard deviation are, so we can proceed with the z-test. Now that we know we can proceed with the z-test, the next thing we want to think about is, well, what are we talking about? So that means setting up our hypotheses as well as the claim. In this case, I am making a claim, and my claim is that the mean that we're talking about here, mu, is something other than the supposed value of 68. Remember, that market research indicates blah, blah, blah. That's not actually the claim. That's just our supposition. In this case, the supposition being that mu is equal to 68, where we also have that standard deviation given of 3.5. Just keep that one bouncing around back there somewhere. It is important to know, but this guy here is our claim. This is our alternative, and that is the null. Where, again, the structure kind of gets in there, and usually the alternative is the claim, because it's kind of sometimes called the testing hypothesis is one of the names you might hear for it, where again, it's specifically about testing that potential change. Here, change is exactly the right word because we're taking the not equals case. But anyway, those are our hypotheses. Then we want the level of significance alpha, which in this case I have picked as the traditional value of 5%. Why it's traditional? No good reason, but it is. Where, because we're looking for any form of inequality, we know that this is going to be a two-tailed test that we'll be working from. So if we want to get our test statistic, we get z 66.9 along with that mu value of 68 divided by sigma 3.5 divided by the square root of the standard deviation, which here is 25. Hey, it's a nice one, and it's always nice when that happens. But spit all that out, and we will get a z-score of about negative 1.57. So, if we want to get some sense of what this looks like, we can give ourselves a distribution type picture, which will spoil the next part of the problem, but that's okay because the picture is more important. Anyway, that picture shows us what we're looking for with our two tails like so, where the z-score, as I said, gets flipped over. Remember here, the x-bar value is below, but because we are looking for a two-tailed test, we get its opposite above to bounce it out. And as a result, we want to get that p-value. We're taking the areas below our real, as it were, test statistic, as well as its not-so-real counterpart, which we can get using normal CDF or the table, or most efficiently, the z-test function in the calculator, where you run through, you plug in these numbers that we have here, and as a result, you will get a p-value of about 11%. To be more specific, you get that p is approximately 0.1164, where most importantly, that p-value is a fair amount bigger than 5% or alpha. So because the p-value, that 11%, is bigger than alpha, we're saying that it's not suitably unusual. Again, 11%, that's pretty close to the borderline for what I would consider unusual, but it's not quite enough to say that there's definitely something wrong here. And, well, if you don't even think about all this context, that kind of makes sense, right? Because, well, my mean it's only a little bit lower than what the market research indicated. So even though that 11% makes it seem pretty significant, not so much. And as a result, because the p-value is bigger than alpha, we can say that we fail to reject. To reject is two words. I know that. I'm just bad at kerning. The null hypothesis. So, because we are failing to reject the null hypothesis, when we want to make our final conclusion, we would say something to the effect of, there is not enough evidence for alpha equals 5% to support the claim that the mean number of videos watched online per day by Gen Z is not 68. Whereas I said, you probably want to use the z-test, you probably want to get comfortable with the z-test here, but your choice is your choice. Whatever gets you to the answer, that's the important part. And the last thing we'll do here in this section is get a little bit of practice working with critical values as well, just so you can see both sides of that coin. So you can see both ways that you can approach this kind of problem.